Hello, this is the latest demo of my relay simulator. I've designed this to enable me to work with relays, relay logic, to eventually build my own 12-bit relay computer. I've been trying to find tools to allow me to simulate relay logic, and I've not found anything that was suitable. So I decided to take the plunge and write my own tool. Um, in this tool, you can drag components from the side here. For example, I draw a switch and then an indicator, and you can wire them together with wires. Um, so what I've done here, I've prepared a number of examples, and you can see what this can do. I'll start the simulator, and now the simulator is running. So the first components you can do are switches and LEDs, and you can see here if I press the switch, the LED is connected via a wire, the LED comes on. The switches can be toggle like this, or they can be momentary action, and also you can see that we can put different make all the components different colors. You can wire together junctions and waypoints, so you can see here that I've got two switches, 1 and 2, and a number of LEDs here that are all connected in different ways, and you can see why the switches and the LEDs have these 4 pins. And what I found quite frustrating with things like Logisim was you always had to keep on turning the orientation of an LED or a switch to the right orientation, and I felt it slowed me down. So I've made these switches and LEDs only to have a single have 4 connections, but they logically work as a single pin. So on here, if I turn this switch on, you can see that all the LEDs have been lit, and if you can imagine here that if power is going into this single pin, which is these 4 lugs, it would also get transferred to this other switch. And again, I can hit this switch and everything lights up. This is how how the wiring should work. What you can see here is I've turned this switch on. This switch here has gone dim. It's not off, it's gone dark. What it means is there's power running through this switch, but it's not actively driving itself. So you get an idea that its power is going through it from into the connector, but it's not actively driving. And you can also do multiple wires onto a single pin. So you've got a full ability to connect components together. Here we've got the clock. So I have a clock control which can go from once every 8 seconds down to I think it's 0.4 hertz. And you can see here the clock's flashing and driving these 2 LEDs. And again, you can also see here that the clock was back driving the switch. Now, if I turn the switch on here, what's happening? Well, the switch has gone high, so this is driving through the clock these 2 LEDs permanently high. The clock's still working, but this switch is almost like overriding the clock, which is how it would work in kind of real life. So I'll put that back and I'll turn the clock off. Here I've implemented a diode, and you can see if I turn this switch on, it powers through to this LED. But if I turn this switch on, it only powers here, it doesn't back drive through the diode. And finally, VCC. VCC is just a permanently live connection that will always keep that LED lit, or any logic high. Relays. So here's a basic relay. I've got a switch on the coil. In my relay logic, I don't need ground because all relay coils are connected to ground, so that's all been omitted. And you can see here I have a VCC supply here, which will drive this LED, and I have a VCC supply here which will drive these 2 LEDs. What I'm demonstrating here is the relays are completely bidirectional. And if I just toggle this relay on, you can see that this VCC power is now driving this LED, whereas the VCC power here is now driving this red LED, and we can toggle to a heart's content. And we can also do things like latching relays here. So in this example here, once I press the switch, the VCC from here will go through and keep this relay sustained. So if I switch that on, this VCC is now also powering the coil of this relay, and I turn it off. You see here that the switch has gone to a dim. It's being now driven by this line, but it's no longer actively powering the relay. I can turn that on and off to a heart's content to make no difference. And the only way now to clear this latching relay would be to stop and restart the simulator, as it should be. Here we have links. So in order to have lots of circuits, they can be spread across multiple pages. To connect the pages, you have links. Links here. If I press this button here, this link object here is enabled. It goes high, and because these two link objects share the same name, link 1, this LED will also be driven high. But you don't actually also have to use these link objects all the time. Switches, LEDs, and a couple of other components also have built-in links. So in this example, this is called link 2. I've set this switch to have a link name of link 2 and this LED. If I press this switch, you can see that because this switch and this LED have a shared link name called link 2, they both are lit, and but this switch can also drive conventional links. So if I just stop the simulation for a second, and we can look at this switch here, you can see here that the link name of this switch is link 2. Link for the name for this LED is link 2, and this link component's name is link 2, and that's how you connect components together via links. I'll just start the simulation again. And again, links are also bidirectional. So here, if I turn this switch on, you can see I'm driving this LED, but also via the link that this switch and this LED share, I'm also driving this LED and then going through and driving the switch. And if I turn this switch on, you can see the switch is in driving the LED. This LED has a link which goes to this switch here. They share the same name, and then this is then driving the LED that way. So everything is completely bidirectional. Buses. I've built a basic bus component, and this is the bus component here, and as you can see, I've put a number of switches and then one a bus component, and here a number of LEDs. So if you see here, the bus is called bus in this example. Its starting pin is 0, so it goes from bus pin 0 to bus pin 7. There's 8 pins. There's the 0 to 7, and there's 3 spaces in between each pin, so I can spread the bus out a bit. And again, the same on this bus component here. It's a copy. So if I run the simulator, if I switch wires on this bus, you can see they transfer out onto this bus component here and light the LEDs. What I can also do is split out part of a bus. So this component here, partial bus, it's still called bus, but what I've done is I've told it, if I stop the simulation, that I want it to start on pin 4 and have 4 pins. So it's only, so the pins showing on here is bus 4 to bus 7. And this can come in handy when working on parts of circuits as well. You don't want the whole bus presented, you just want part of the bus presented. But to make life simpler to display buses, I also have this display component. And here you can see the bus is called bus, and it's connected to pins bus 0 to bus 3. So if I start the simulation, if I turn these pins here on, this partial bus goes high, but this lower part of the bus is being mimicked by this bus display. Working with buses and switches is all well and good, but it can be quite tedious. So what I've also got here is a thumb wheel and 7-segment display components. So here, if I just stop the simulation, I've now called this bus data bus, and this hex display here, I did this one first, is connected to pin 0 to pin 3. This thumb wheel encoder is also connected to pin 0 and pin 3. This hex display here is connected to pin 4 to pin 7. And it starts, how it's controlled is started by pin 4 here. So you say which pin is your start pin. And same with this encoder here. It starts at pin 4. And here I've got a data bus component showing all 8 bits of the data bus. So if I start the simulation, I can set a bus quite easily with these thumb wheels. I can see the value in hex on these hex displays. The C's on here just basically quickly clear the bus, the thumb wheel back to 0. The final component is memory. This is a bit of a cheat for my project because I need a simple static memory to write my programs in. So what I've done here is I built a memory component. If I stop the simulation, we can edit it. And here you can specify how many address bits for the memory. Here I've done an 8-bit memory, and how many data bits for the memory. So you could have 4, 8, 12, 16 data bits, and the same for the address bits. It's completely dynamic. It will handle whatever size memory you want. The address bus is called address. The data bus here is called data. I can also choose whether this memory is volatile, so every time you start the program it will wipe and start from 0, or if it's not volatile, you can write a program in here and keep the program static and loaded all the time. I can also load and save memory files into this memory as well. So if I've got a program that I've already saved, I can load it into the memory here as well. If I just start simulation. So what can I do with this memory? So what I'm going to do is, first of all, at address 0, I'm going to add the value 2 to, sorry, let's do that. For address 0, I'm going to add the value of 2. And if I enable the memory and hit write, you see that value 22 has been stored in address 0. Now in address 1, I can go (5.5), and now I'll write 5.5 to address 1. Now if I go back to address 0 here and hit read, you can see that 22 has been put onto the data bus. And then if I go to address 1 and read, you can see that 5.5 has been put on the data bus. I can also, in the memory here, add data rather, manually. If I want to edit a code or a program, and you see here, so if I go to address 4 now and hit read, I got the value 5.6. which is what I put in. So they're the components of my relay computer simulator. My relay simulator. It's written in Python. If anybody's interested in helping me with the project, I'll love to put it up on GitHub. I'm not a great coder, so don't expect wonders with the code I've written so far. My goal would be to turn this into a much more fully featured simulator for relay logic. And we can add more components here, so more types of relay, timer delays, etc., etc. And I'll be interested to see where people want to take this.